great to see everybody here. I see a lot of familiar names from the past, which is awesome. My name is Braxton Landseal. I manage our developer adoption team, which includes everything from our technical support. So you find us in Discord and on the forums, helping you get unblocked. Our partner engineering team, which is working with our larger strategic partners, building sample code on our GitHub, things of that nature. And then our technical documentation team, so all of the guides, API reference, tutorials, feature pages, all that information is part of the documentation team. Yeah, and for that, I've been at Niantic for about 2.5 years. The first year and a half, I was on the partner engineering team myself, so I got to do a lot of these. I don't get to do as many of these anymore, so this is kind of a treat for me, and I see some familiar faces, which is always fun. So happy to be here. And I'll popcorn over to Evan.
Hey, my name is Evan. I'm a developer support engineer on the 8th Wall team at Niantic. We do a lot of similar things that Braxton's team does, just on kind of the website of things. So if you've ever reached out to support@8thwall.com or posted in the 8th Wall forums, there's a chance we may have interacted. And yeah, I love teaching developers how to build cool location-based AR experiences with VPS.
Awesome. Thanks, Evan. And I will take it away from there. So I think the first question for those who aren't familiar is, what is VPS? VPS stands for our visual positioning system. It is our kind of our flagship location-based tool. What it allows you to do is to anchor your virtual content to real-world locations with what we tout as centimeter precision accuracy. So that's being able to go to a place, put an experience or put an object there and have it be hyper accurate from session to session and not move very much. You can also access the 3D mesh of those real-world locations. So if you want to be able to curate an experience very specifically for a landmark or a fountain at the park near your city or your place, you can get the mesh for that to be able to test your stuff ahead of time, to be able to understand how things are going to react and curate the experience very, very precisely. And then you can share those location-based experiences. 8th Wall is our web-based platform, and then Lightship is our Unity mobile tool. So choose your platform. There are different use cases for each one sometimes, or maybe you have a use case that fits both. But we have tools to allow you to meet you where you are and where your development skills and needs are. So VPS locations. Let's talk about what those are. So these are unique locations in the real world. These are things that have a lot of features. These features can be geometrical points, so things that are very like obviously unique. It can be colors. It can be a variety of different things. Essentially, locations that are easy for us to interpret through the camera lens and match up with what we have in our database, and match those two things together to understand exactly where you are. So let's look at this example of this statue, and because we have very precise 3D geometrical data on this location, when you are using your phone and your camera to tell us, hey, look, I'm at this VPS location, do you recognize this? We'll be able to reconcile that and say, oh, wow, yeah, we know exactly what that is. And because of the camera frames, the images you're sending, we know exactly where you are. And then your experience can start from there. There are two different types of VPS locations. Public locations are used for production projects. So anybody can find these public locations. They're the ones that we tend to have the very best data on. And then test scans or testing locations, more for your own testing, as the name suggests, for personal projects. Maybe I have a bench in my backyard that has always been a test scan that I've used many, many times just to test a VPS thing, but nobody else can use that bench because it's in my backyard and we don't want anybody else to be walking and wandering around in my backyard. So you have scans for your public application and for your own testing purposes as well. And then the geospatial browser. So this is our map on our web portal to show you what VPS locations there are in the world, give you some information about those, and show you the mesh that we have those for those locations as well. It's kind of our entry point for both 8th Wall and Lightship to, you've identified you want to make a location-based experience. Well, now let's go see what meshes are available, see what locations are available, see the quality of those locations, how much data do we have on those locations, and then ultimately, if you want to use that location in your application, we won't dive into exactly how to do that yet, but there are some information, some key fields that you'll need to get from the geospatial browser as well. It's essentially our 3D map of the world. At Niantic, we're really trying to get a full 3D geometrical understanding of all locations in the world. So this is part of our journey in doing that. It's also your repository to check out your public locations and your test scans. So you have a way to filter between, hey, I just want to see the test locations I have, or you can look at the publicly available ones that are available to everybody. We'll dive into that both on the 8th Wall and the Lightship side here shortly for the workshop. And then your localizability score and alignment score. These terms or grades are to help illustrate how much data and the quality of data we have on locations. So as an example, if it's your first time doing a scan of a location, the location is not VPS activated yet, you might not know how to take a really good scan yet. Maybe you didn't quite catch all the best practices. So you go out, you take a scan. It's an okay scan, but it's not the best. It's not the highest fidelity scan in the world. It won't be production quality yet. In fact, I think we need like 5 to 10 scans for it to be of a higher quality. Essentially, these scores are meant to show you, the developer, how reliable these locations are, how much data we have on them. So for production application, for example, we would generally suggest only using the good or production quality levels locations. Fair or experimental, lower chance, lower probability of users being able to localize against that location. But that means that you can add more scans to bring that quality up and help get it to the good production quality. And then test and private scans have the lowest localizability, and that's because they really only have one scan attributed to them. Because they're a test scan, we don't allow developers yet to scan a whole bunch of times, provided a whole bunch of different versions of the scan. It's just one scan meant for testing purposes. And you'll see good in production, fair and experimental. Depending if you're on 8th Wall or Lightship, the terminology is just slightly different. And then for Wayfair, I will kick it over to Evan.
Sweet. Thanks, Braxton, for the great introduction on VPS locations, the geospatial browser, and localizability. So we've kind of learned that we have this 3D map of the world that's continuing to grow day by day. How do you actually contribute 3D scans to that map, or how do you add new locations that are already a part of that map? So to do this, you can start with either the geospatial browser or the Wayfarer app. The Wayfarer app is a native application you can download on iOS or Android. You can view and nominate the locations that exist in this 3D map that you can use to build AR experiences. You can create test scans, contribute scans to existing locations or to locations that you just nominated. And you can also test VPS localizability to see if this location is a good candidate for an AR experience before you kind of put the effort into building an experience around it. If you don't have this app yet, we have these 8th.io links, Wayfarer-iOS and Wayfarer-Android, take you to Test Flight or the Google Play Store to get them downloaded. We also have a QR code. You can just scan this to download it on your device. All this information is also in like a resource guide in our documentation, so you can look at it later as well. Cool. So we're not going to go too deep into the scanning and activation process, but just to kind of give a broad overview, here's kind of what the process for activating one of these VPS locations looks like. And by activating, we mean like to activate a VPS location, you have to take 10 scans of a location. And then when you activate it, those scans are kind of fused together to create kind of a larger mesh that we can use for localization, just so we have more data. And we like to see these scans happen at different times of the day, perhaps in different weather conditions, just so that that kind of accounts for the different kind of environment and circumstances that actual users will be using this experience at. So to activate one of these locations, you're going to select the location in the geospatial browser for Eighth Wall. You can also do this in the Wayfarer app. You're going to scan that location 10 times if there's no existing scans. Otherwise, you'll just want to make sure it gets to that 10 threshold. You'll upload those scans, and then you can just kind of press the activate button. It takes a few hours until you're able to pull this up in the geospatial browser and take a look at the scans that you can use in your experience. Recently we had a whole webinar on scanning best practices, which will also be included in our resource guide. Just some quick tips. Check the weather, like rain is totally okay. If like it's really dark outside, that might not be the best time to scan your VPS location. People probably won't be using your experience, like in the middle of the night. Devices with LiDAR will create better scans on the mapping side, but you can also use a device that doesn't have LiDAR. In fact, it's actually preferred if there are scans from both devices that don't have LiDAR and scans from devices that do have LiDAR, again, just to account for the different devices that users will actually be using to localize against your VPS experience. Obviously, make sure your mobile device is charged. You're going to be out in the field. So just kind of like all other Niantic games and just events, make sure you have some battery before making your way out into the field. Plan your route. Make sure you know where you're going. Sometimes people will be, traveling long and far to activate a location. Can't always be on site. Make sure if this already doesn't exist as a VPS location, that you nominate it before going out and trying to scan it. And then lastly, I'm going to briefly kind of explain the difference between a bespoke VPS experience and a procedural VPS experience. The experience are kind of summed up by their names, but bespoke experiences are experiences that are designed for a single location. And those are the experiences where we will download a specific mesh of a location from the geospatial browser, and then we'll use that mesh to position content. Maybe we'll use that mesh, we'll pull it into Blender to create a baked animation. These bespoke experiences are very specific to a single location, and they obviously can't be experienced by everyone in the world, just by people in a specific location. On the other hand, procedural VPS experiences are designed to use any detected location. So these are a little bit harder to develop for, but they're much more scalable. And how this works on the back end is you're not actually downloading a mesh before you're building this experience. You're actually getting that mesh returned at runtime, and we'll kind of align it to the real world. And then you can use that mesh however you'd like. For example, tap on the mesh to kind of plant flowers or something like that. So procedural, basically everything is happening at runtime, whereas bespoke, everything is kind of happening beforehand. You're kind of building this experience out before the user even kind of localizes against the mesh. So we have more information on this on our documentation, but that will lead us right into our VPS workshop.
Yeah, thank you so much for this great background information, Braxton and Evan. Alrighty, so now comes the fun part. Something we're trying for the first time here, which is to try and get everyone that's learning and want to play with Lightship to join a new Zoom, which is I dropped it in the chat earlier, but here it goes again. So for those of you that want to join the Lightship workshop, let's go ahead and move over to that. I will be over there in just a second to let everyone in, and then to also hand over the reins to Braxton, Ricky, and a couple of the support engineers who are going to be on that side answering questions. Both rooms will be recorded, and we will make a post for Lightship cutting out the Eighth Wall side, and we'll make a post for Eighth Wall cutting out the Lightship side. So we will record both in case you want to do both, because you can't in Zoom. That way you can learn eighth wall today and Lightship tomorrow, or vice versa. So without further ado, I'm going to go ahead and let Evan take over the screen sharing here so he can go ahead and kick off his workshop for eighth wall. And for those of you joining us in the Lightship side, we'll be over there in just a second to let everyone in.
All right. So for this VPS workshop, if you don't have an eighth wall account already, you can sign up really quick. I do recommend you try and follow along if you can. Otherwise, you can just sit back, kind of take it in. Again, this is going to be recorded, so you can always go back and follow this workshop on your own time. All of the steps we're going to cover today are also documented in our template project that we're going to start with. So don't feel pressured to kind of keep up. If we're going too fast, you can always look back at the documentation and catch up. Cool. So kind of just to cover our learning objectives for today. One, we're going to learn how to add a VPS location to your eighth wall project using the geospatial browser. We'll add a 3D model to the scene using the A-frame inspector, and then we'll kind of test this VPS location just to prove to ourselves that we can develop a VPS experience. So here's one that I built last week, just a really simple experience. This is our office in San Francisco, kind of this TARDIS, Doctor Who TARDIS, and just placed Dodie right in front of the speakeasy entrance right here. So this is the experience we're going to build today. Really simple, just adding a 3D model onto a VPS mesh. Okay, so the first step is to create your project in the eighth wall console. eighthwall.com/projects leads to our project library, where we can start with the A-frame VPS template project. So you can go to eighthwall.com/projects, type in VPS. There's two of these projects that look really similar. One of them is A-frame and one of them is Three.js. We're going to be using A-frame today. It's typically easier for beginners. And if you don't have any experience with A-frame yet, A-frame is really similar to HTML. And it basically provides declarative, like tags for 3D objects, like a plane, a sphere, a entity for something like a 3D model. So this makes it really easy and fast to pick up. Once you've located this project, if you're following along, you'll clone this project into your own workspace. Once you click the clone button, you'll see something like this, where you can specify which workspace you want to clone this into if you have multiple. You'll also specify a project URL. For this, I just used Dodie VPS. And then it'll ask you to select a license type. There's demo, educational, commercial, non-commercial. Typically, I'll just choose demo use. Unless you're actually building a commercial experience for a client, then you would choose commercial. For this is just a demo though. Once you've filled out all of this information, you'll hit create. And that should then, after a few seconds, create the project in your workspace. And if anyone is following along, can we just get, once you're able to clone that project into your workspace, a check mark? I believe you should be able to give a reaction. Looks like Pablo gave us a thumbs up. Okay, cool. And if I am going too fast, or if you need some time to catch up, feel free to just throw up one of the X reactions, and we can backtrack a little bit or wait for you to catch up. Cool. So now that we've cloned our project into the eighth wall console, we are getting our first look at the cloud editor if you haven't worked in it already. So this is what you're going to see once you open up your project, once it's been cloned. You'll see different files on the left pane, starting with head HTML, app.js, and body HTML. I think body HTML opens up by default. This is kind of like the meat of our experience. This is where we're adding all of our 3D content. So that's going in our body.html. We're going to add our 3D model into the assets pane. And then we will save our code with the save and build button at the top. And we'll also use this preview button to open up a 3D view of our experience to place our 3D model relative to the VPS mesh. We'll also then use the preview button to scan a QR code and test the experience on our mobile device. Cool. So now that we've gotten a quick look at the cloud editor, we're going to take a look at the geospatial browser and learn how to add a VPS location to our 8th wall project. So the geospatial browser lives in the cloud editor. Once you have a project open, you'll see this map icon on the left sidebar. When you click on that map icon, this will bring you to the geospatial browser. And you can kind of explore this map, type in an address, perhaps where you are now, or somewhere you have an idea that you'd like to build your VPS location. And you can kind of explore the different VPS locations there. There's also this not activated filter in the lower left corner. So if you are looking at like nearby where you live or someplace where you want to create this VPS experience and you don't see something already there, be sure to toggle that to see if it is already a VPS location, but maybe it just hasn't been fully scanned or activated. Once you click on one of these locations, you can see a carousel of scans. You can use these left and right arrows to look at the different scans that are available to use. So this is the one that I'm going to be using today. It's a really high quality scan. This is kind of the sort of thing that, the sort of quality that we're looking for in a VPS mesh. This is kind of a 3D model viewer as well, so you can also rotate it around, zoom in and out. All right, and then you'll notice this add to project button in the lower right-hand corner of the mesh viewer of this carousel. This is how we add the mesh to our project. So this is going to add a specific mesh from the carousel to our project. So make sure you click this button when you are viewing a high quality mesh, because that's the mesh that is going to be used for basically that we're going to pull into our experience to use as like an occluder material and a shadow material. So the higher the quality, the mesh, the better that this is going to look in the experience. I also want to note that once you add this to your project, it creates a row below the map and mesh viewer. And at the end of this row, you'll see a cloud icon with an arrow in it, kind of a download button. Then there's a trash icon right next to it. If you want to remove this location from your project, you would hit the trash button. If you want to download the mesh to pull it into your experience or bring it into Blender to create a baked animation, this is where you're actually going to download that mesh. There's also a little arrow next to kind of the legend above it. It says GLB. So this is going to download the GLB model of this VPS mesh. If you click that little arrow next to GLB, it's going to create a pop down, a drop down that gives you different mesh export settings. And since we're just going to be using this mesh as an occluder material and as a shadow material, we really want to prioritize performance. So I highly recommend selecting low poly, no texture in the mesh export settings before you download this VPS mesh. So again, at this point, all we're doing, once we've found a good quality mesh, we're selecting that mesh, and then we're changing the export settings to no texture, low poly, and then we're downloading it by clicking that button right there. All right, and if you're following along, would love to just get a thumbs up or a check, see where we're at. Also feel free, if you're not exactly following around, just to kind of poke around in the cloud editor and see if you can find all of these things for yourself. Okay, I think we're going to move on. And now we're going to add a 3D model to our project using this mesh that we just downloaded from the geospatial browser. So now that we have added our VPS location to the project and we've downloaded the mesh of that location, we're going to return to the cloud editor, click this code icon, the left sidebar. We're going to drag and drop our 3D model into our project. Today, I use this Dodi GLB model. We have an 8th.io link if you want to download this yourself, if you want to follow along, 8th.io/Dodi GLB. And we're going to drag and drop, once we've downloaded this model, into this left panel. So you can see here, Dodi GLB. And now we can actually click on that model and see it in the model viewer. So this is the model we're working with today. You can also change the names here by clicking the 3 dots if you want to rename your own model. Cool. So we just added our first asset into our project. This is kind of the first change we've made in code. If you're following along and need time to catch up, feel free to do, the thumbs down or X emoji. And then also, yeah, if you have any questions, please throw them in the chat, and we can address them at the end. Cool. So I think a thing that we missed here. So we added the Dodi model, but we're actually going to be adding the mesh that we downloaded from the geospatial browser as well. That's what this terigaki-cafe.glb is. So this is what it looks like when you kind of put your VPS mesh in the cloud editor. So we have both of those assets in here right now. We have the mesh from the geospatial browser and our Dodi 3D model. Here on line 14 of this project, this is within the A-frame asset management system. On line 14, we have this asset item that has the ID VPS mesh. And here's where we're going to provide a relative path to that VPS mesh that we just added to the project. So you can, to do this relative path, you're always going to start with /assets/ and then you'll do the name of the mesh that you downloaded from the geospatial browser.glb. And similarly, on line 16, 2 lines down, we have this VPS anim, and we're going to set that asset item to be Dodi.glb so that we're loading. All this is doing right now is loading our 2 models into the A-frame asset management system. We're not actually doing anything with them yet. We're just loading them. Basically, what assets does is it makes sure that all of your assets are loading before dismissing the loading screen, so that if you start the VPS experience and localize, like, you don't have to wait for your models to load in. It kind of starts instantly. You do get all of the loading out of the way up front before the experience actually starts. So right now we're just loading those models using the asset management system. Now we're going to grab the name of the VPS location from the geospatial browser. Again, we'll click the map icon on the left side. And then in the row that was added, once we added the VPS location as a project location, you'll see we have like a location title and a name. We'll be copying the name. So this one is entrance-ves. So that's what we're going to copy. And then we're going to go back to our code. And on line 26, we're going to paste the name of the location that we added to our project. So if you've just cloned this project, this would say name my-location. You're just going to replace my location with the name that we just copied from the geospatial browser. And basically what this named location component does is it hides all of the content that is a child of it. So it will only show once we've localized against this specific VPS mesh, and we know for sure that it's going to be aligned in the real world. Cool. So if that makes sense, or if you're following along, would love to see a thumbs up or a check mark. Similarly, if anything doesn't make sense or you have a question, feel free to throw up any other sort of emoji. Okay. So we're going to go through the process of now developing a VPS experience. Now that we have the basics down, we have our models loaded into our project ready for use, and we have specified in our code which VPS location we're going to localize against. Now we just kind of have to add the content. So remote authoring refers to kind of the method of adding 3D content which without actually being on site at the VPS location. I developed this simple VPS location where I added Dodie to this VPS mesh without ever actually going to the location until I was ready to test it. So that's what we're going to do today. And there's two ways to do this. You can do this in 3D modeling software if you're familiar with Blender or Maya. You can also use the A-frame inspector and do this all within the cloud editor, which is the method that personally I prefer. I feel that it gives you a little bit more flexibility to do things at runtime rather than baking everything up front in 3D modeling software. So we'll use the A-frame inspector to position our content, and then we'll basically position things in code rather than using 3D modeling software. To do this, we have provided a desktop development component, which takes out all of the AR specific things about this project so that you can just open this in a vanilla A-frame or 3D view. So all you have to do here is add desktop-development, make sure you're adding it inside of this right caret as it's a component that's being attached to our scene. So once you add this desktop development component, save and build, wait for it to finish building the project, and then you can click on the preview button to open up the experience in a new tab. Once you open it up in a new tab, you should see something like this. So hopefully the A-frame inspector opens up automatically. If it doesn't, you might just want to refresh the page, or you can use these handy shortcuts to open them up, open up the A-frame inspector. So what we see here is our VPS mesh, and then we see a tiny little Dodie. Dodie is just positioned at 0, 0, 0. And you'll notice that the VPS mesh has some offset. It's not perfectly centered or at 0, 0, 0. This is very typical. Sometimes the VPS mesh can even be a little bit far off from the center, but it's important that you don't move that VPS mesh. You're going to want to align content exactly as the VPS mesh comes in. So even if it's a little off center, please don't change the position of that mesh. Only change the position of the entities that you're adding to the scene, in this case, the Dodie model. Okay, so at this point, to start developing our bespoke VPS experience, we've added our desktop development component to the scene, save and build our project. We previewed it, opened it up in a new tab, and then we have the A-frame inspector open. And now we're ready to start positioning our content and really start building our A-frame experience. There's some shortcuts to, you can see in this video here how I'm kind of positioning Dodie. We have these 3 buttons in the top right corner of the A-frame inspector. We have these crossed arrows, this almost refresh symbol that stands for rotate, and then the scale symbol. So you can click on these different buttons in the top right corner to rotate your Dodie model, scale it up, and then reposition it. As we're making these changes, you'll notice these values on the right panel updating. So we have position, rotation, and scale. As you see, I'm moving that position, those values are updating. If you prefer keyboard shortcuts, we have these over here on the left side. You can use W to position, E to rotate, and R to change the scale. Again, do not move the VPS mesh. We're only repositioning the entities that we're adding to the scene, in this case, our Dodie model. now that we've positioned this model how we want, I guess if anyone is playing around with the A-frame inspector, I would love to get a thumbs up, or similarly, if you're having problems, give us any other sort of emoji.
Hey, Evan. Yeah, so I made the oopsies that you said not to do, which is moved the mesh. And I imagine that can be pretty easy to do by accident. So curious, what is like the step to fix that?
Yeah, so the A-frame inspector, this isn't like 3D modeling software where if you move something, like you have to like undo it or like work back, because none of your changes are actually saved in the A-frame inspector. So, like everything that's happening on this web page is completely local. It's almost like a testing environment. If you just refresh the page, everything is going to snap back to the positions that they are defined in code. Nothing is actually changed until you add something in the code. So if you accidentally move something, I'm not sure if Command Z works, but worst case scenario, you can just refresh the page. Everything will snap back to where it started. Definitely have done that a few times as well. Um, Another trick here is if you can't find your VPS mesh, like if it's really off center, or if you can't find your model, maybe it's just really small or hidden even somewhere within the mesh. A good trick is to give your model an ID. Um, I think we'll see that a little bit later, but you can see here I have given my uh, this Dodie model an ID, and you can see right here, I see it on the scene hierarchy on the left. It's called Dodie model. So that's how I can kind of identify this entity in the scene hierarchy. And if I can't find my model, you can just hit the F key and it'll find that entity in the scene. So that's another trick as well. If you like move something and you're not sure like where it is, just select it from the scene hierarchy and hit F. Another common issue that people run into. Okay, now that we've positioned Dodie how we want to actually persist these changes so that when we refresh the page, Dodie remains in that spot and doesn't snap back to 0, 0, 0. So earlier we saw these position, rotation, and scale values updating. Now is where we're actually going to copy these values into our code. So you can see me just kind of doing this one by one. I added a position component, position equals, and then I just copy and pasted these values into my code on line 34, which is our Dodie model. I'm going to do the same thing with rotation and scale so that we end up with something that looks like this. Here you can see this is where I added my ID equals Dodie model, which is how I was able to find it in the scene hierarchy of the A-frame inspector. And then I've also defined GLTF model equals hashtag Dodie on line 34. This references the Dodie model that we loaded into the asset management system earlier. And then these are the three components that I've just added. I've copied these values from the A-frame inspector after I positioned it how I wanted to. So now that I've added a position, rotation, and scale to my entity, if I refresh the page, now Dodie is going to remain where he was, and he's not going to snap back to 0, 0, 0. So every time you refresh the page in the A-frame inspector, things are going back to how they're defined in code. So as long as you don't add a position, rotation, scale to the VPS mesh, then you'll be good to go. Just make sure you're adding these two entities that you're adding or trying to augment the mesh with. Cool. So again, we just added position, rotation, and scale. We're going to save, build, preview. Again, wait for the build to complete, and then this QR code won't work for you, but you'll have your own unique QR code when you preview this. Scan this on your mobile device, and then you can test this out yourself. All you need to do is scan the location, and you should see something like this. You should see a Dodie model positioned out wherever you positioned it in your own VPS mesh. I also added, so the model should be animated by default. We have this component on it called play VPS animation. if you're working in the project yourself, you'll see that around line 34. But yeah, this is kind of how easy it is to get started with building VPS experiences for the web. Again, you could also take these steps in 3D modeling software like Blender if you're more comfortable with that. But you never have to leave the cloud editor if you don't want to. And yeah, I find the A-Frame Inspector kind of a great tool for getting started, especially if you don't have any 3D modeling software experience. And with that, our workshop is complete. A really simple VPS experience, just covering the fundamentals today. But let's see, today we added our location to the geospatial browser. We added Dodie, a virtual object, to our mesh using the A-Frame Inspector, and then we were able to test it and kind of see our location come to life. Here's some resources you can look over if you have more questions or want to spend more time diving in a little bit deeper. We have a lot of information on VPS in our documentation. Our project library is a great resource. We have A-Frame, 3JS, Babylon.js sample projects. Our forum is a really great resource for just connecting with other developers, asking technical questions, finding answers to questions that have already been asked before. And then also highly recommend watching our VPS for web quick tips video. This tutorial is about 5 minutes and it covers basically the exact same thing that we did today, just placing a cube relative to a VPS mesh. Again, 5 minutes. If you want to kind of redo the session and pause it as you kind of do this yourself, is a great way to get started. And this is on YouTube. Cool. So now it is time for Q&A. I will take a look at the chat, see if there's anything there.
There's one question in the Zoom Q&A, but from Hugo, which I think is now in the Lightship side, but this might be good for everyone to kind of understand, which is essentially the question is, they did scans of a location, but when they asked to reactivate that location, it merged his new scans with some existing scans. And they kind of saw that as an issue. I think Braxton offered somewhat of an answer to it, but would love to hear what you think, Evan.
Yeah. So, yeah, so some of these locations that show up in first-party Niantic games like Pokemon Go, players can be incentivized to scan these locations for in-game rewards, like poffins or depending on the game, you get some sort of reward for scanning. So sometimes these scans aren't really great. Players are just kind of doing them to get rewards. So yeah, sometimes you do end up with kind of useless scans. Hopefully those scans don't get pulled into like good quality scans. If they do though, they likely wouldn't, as long as you have a high quality scan, they shouldn't really affect localizability. The important thing is to, if you're adding 5 to 10 new scans, hopefully you'll see a new scan appear in the geospatial browser. And really what's important is that you're selecting the high quality mesh. All of the other scans don't really matter, especially if you see that unaligned warning in the geospatial browser, which a lot of the ones from Pokemon Go, the really low quality scans probably aren't going to be aligned to the fused mesh. But if you are reactivating a location and you're seeing a lot of like artifacts or just like they're kind of like messing up your scans, we have a mapping team that's here to help with that. So feel free to reach out to support@8thwall.com or support@lightship.dev, depending on your platform. And our mapping team can always take a look and try and help clean some of this stuff up.
Thank you, Evan. We have a question from Alessandro in the chat. How did you manage to capture an indoor location? I've tried that dozens of times and always results are poor in regards to the scans.
Yeah, this is a good location. So it is a good question. It really depends on the location, I'd say. But VPS can definitely be used indoors, and we've seen a lot of people use it indoors. It does kind of depend on the feature points, primarily like the environment that I use today is very, asymmetrical, had a lot of feature points, and it was really well lit. So if you're trying to scan an area with say like reflective floors and like white walls, like that's not a good candidate for a VPS location. The reason that this one looked really good is because there were so many unique feature points, and it was really easy for Wayfair, the scanning app, to kind of like map this area with all of those feature points. But we have seen people try and scan like an art gallery that has like a concrete ground and like white walls, and that just doesn't perform quite as well. And the scans themselves don't look as good either, just because there's not as many feature points. So yeah, things to stay away from are like repeating patterns, reflective surfaces, and kind of just like solid color, like featureless walls and floors. But yeah, VPS can definitely be used indoors. Also, ideally, and you're scanning an area that people aren't walking through, because you don't want to capture people in your scans, and you don't want people to walk past your camera feed when a user is actually using the AR experience, because that can cause them to kind of like move the AR content along with it. So yeah, just keep those things in mind. And if you want to create these higher quality meshes as well, like this one was scanned using a device with LiDAR and without LiDAR. And I think that this one probably had about 15 scans, but it resulted in just 2 scans in the geospatial browser. So keep in mind that whole scan wasn't just a single scan. That was like 10 scans combined into one.